Hello guys and welcome to AI Sciences. I am your instructor Sajjad Mustafa, and today we are going to create a poet or a writer by using Python. So our agenda for today is we will start by loading the data, then we will move on towards data pre-processing, then some model training will be done. Actually a lot of model training will be done. Then we will generate actually some content just like writers and poets, and we'll be doing all this by using Python. So guys, if you are new to our channel, we are AI Sciences, and we if you're going to start your career in artificial intelligence and you don't know how to start it, please visit the links in the description. You will find a lot of courses that will help you as a beginner to start your career in artificial intelligence. So let's get started with our agenda today. So let's go to our coding environment, and here you can see that I have already imported a few libraries. I have imported NumPy for some mathematical operations. Then I have imported sequential from Keras model so that we can implement some deep learning by using Keras. And then uh, we have imported dense layer. Sorry, we have imported dense layer. We have imported dropout layer, and finally we also have an LSTM layer, long-term, short-term memory layer. And then we have some utils. I'll let you know later on where we'll be using all of these libraries. So I have already compiled this cell, and let's compile this one. What this cell will do, this cell will help us or allows us to upload any training file, any file from our local storage, right? So I'll just click on choose files. Let's say I'll go on uh, creating poet writer, and here I have a training file. So don't worry, I'll paste this. I'll paste some link in description where you'll be able to find this sonnets file. So basically sonnets is some writing by the famous Shakespeare, and we are going to mimic Shakespeare by using Python. So we have our file, and let's import it. So let's say text equals to I'll say open, and here I'll paste the name of file .txt, and I'll say read it, and then I'll say text equals to text dot lower, so that we don't face any issue of lower and uppercase letters. And then I'd also say split it on the basis of space. By default it splits on the basis of empty space. So let's run it, and let me have a few more coding cells over here. So let's see how our text actually looks like. So it must be having a lot of data inside it. Here you can see that, and if we'll see how lengthy it is, I mean what is the length of this text variable. So here you can see that it actually has 4224 words. By the way, I am training with a shorter file so that we don't spend a lot of time on training the model. The link you will find in description, that will be containing a complete sonnets file. So maybe you'll be having a larger number over here, right? So don't worry about that. Okay, so now we'll say words. Okay, and here I'll say sorted, and in sorted I'll say list of set of text. Any guess why are we doing this? So let me explain it. So text has a lot of words, so we are converting those words into a set so that there will be no repetition of the words. And finally we are generating a list of words, so in this list of words there will be no repetition, and finally we are sorting it out. And then we'll say number to word, and here I'll say let's make a dictionary number colon, let's say W, or let's say word. So here I'll say for n word in enumerate, and here I'll say words, right? And I want you to guess what are we doing, and meanwhile I'll type the rest of the code, and later on I'll explain what am I doing. So here I'm converting word to n. N stands for number, right? So I'll say word, here I'll say n, and rest of the story is same, right? So what actually what we are doing is we are mapping every word to a unique number, right? and and exactly the same opposite thing again, we are mapping word to a unique number and an, that unique number to a word. Later on these things will be used. Okay, so here let's move on and let's do some data pre-processing. So let me create two empty lists, x and y. Shortly I'll show you why I am creating these lists. So here in length I'll say length of text, right? And what is sequence length? Our sequence length will be, guess a number, let's say 50. Okay, well, it's not actually a guess. Shortly I'm going to tell you why what is this sequence length. So let me tell you what is this x and what is this y and what is the sequence length. So here let's say we have a sample text a b c d e f g h I, and we are creating a mapping of characters. In our code we have created a mapping of words, remember, but here we want to create a mapping of characters just to clear our concept. So let's say this is the text that we have and this is the sequence length that we have. Sequence length is 3 over here, right? So it is 3. Okay, so in x of 0 there will be ABC because sequence length is 3, and y of 0 will be D. So basically x will be a feature vector and y will be the label vector. And x1, the next index would be BCD, next 3 letters, right? These 3 letters. And label would be E. Why next letter is the label? Because we want to actually predict the next word that comes into the content, right? So that's why we will feed the previous number of words as feature vector and the next coming word as the label vector. So here let's prepare our data and let's make a for loop, and I'll say in range from 0 to length minus sequence length, and we need a jump of 1, right? So here I'll say sequence equals to text, and here we'll do some index operations. So from I till I plus, what should be here, I plus, let's say, sequence length, right? And then label would be text, label would be the next letter, right? So we'll say text I plus sequence length. Awesome. So here we'll say x dot append, and here we'll append, let's do some list comprehension operations. So I'll say word to number, and here I'll say word, and then for word in sequence, right? and then again same thing with the y. It will append, guess what, word to number, and here we'll say label, right? So sorry, so what it will do is it will actually get the word that will correspond to this label, right? Actually it will get the number that will correspond to this word. So our training data is basically ready, and now let's run it. Awesome, we don't have any errors. So let's just visualize how x of, let's say, 0 looks like. So it must be some numbers, you can see that. And what is the length of this x? Let's check it out. Its length should be equal to the sequence length. Awesome. And what is y? It should be, since it is a label, so okay, so it's, since it is a label, it is an integer, so it don't has any length. So here you can see that, right? So okay, so let's move on and let's do some data pre-processing. So let's modify our x. So let's say x modified equals to numpy dot reshape. Do we have it? Yeah, we have it. So let's reshape and do some pass x vector to it, or x list to it, and then let's pass a tuple of the dimensions. So we'll say length of x, and then sequence length, and then finally 1, right? So this should be the modified shape of x. Why are we doing this? So actually we are going to implement LSTM, and LSTM accepts input in these sequence of parameters. So first parameter should be the number of sequences, second parameter should be the length of sequence, and finally third parameter should be the number of features. So for that we are going to prepare our x, and then again x underscore modified equals to, now we are going to normalize this. So x modified divided by float. Guess why are we doing this? Words. Okay, so we are doing this so that we can get our result in even floating point numbers, and same the case with y modified. Now we want to convert our labels into our categorical features, or in other words you can say we want to do one hot encoding with it. So this numpy library utils function will help us to do something that we want. It will convert all the y's into categorical features, or it will do some one hot encoding. Awesome. So it has also run. You can again check it out how your x modified looks like. It should look very terrible, and yes, it is looking very terrible. Also you can check its shape. So its shape looks like this, right? So we have these three numbers as we discussed. You should have number of sequences, number of length of sequence, and number of features. Awesome. Okay, so now let's map our model. So let's say model is equals to sequential model. We need a sequential model, and then we'll say model dot add. Here we'll add LSTM, long short-term memory, and in LSTM we'll say we need 400 units of LSTM, and we also need to specify the input shape. So input shape would be equal to, we need to pass a tuple in it, and we'll say x modified of 1 comma again x not at x modified of 1, x modified shape of 1. So we need its first attribute, and we also need its second attribute. These two attributes we are passing, right? So then the third um, would be actually that's it. We needed a tuple, and then we should pass if we need to return something. Yeah, we need sequences to be returned, so that we should be having um, our feed backward model as well. Okay, so here we'll say model dot add, sorry, add dropout. Let's drop some of the some of the layers. Let's drop 20% of them. You can change this number according to your need, right? And then let's again do the same thing, but we don't have to do exactly same thing. We just have to pass the number of LSTMs. By the way, if you don't know what is this LSTM, you need to understand what is RNN, what recurrent neural networks. And if you even don't know what is RNN, you can find a link in description that will guide you to a complete course that will help you learn what are RNNs from scratch. Okay, so these are the number of units of LSTM in this layer. You can play around with these hyperparameters. You can play around with the dropout rate and stuff like that. Okay, and now it's time to add um, a final layer, that is our dense layer, right? So here we'll say y underscore modified. Ta-da! Oh, sorry, I actually accidentally compiled it. So yeah, y modified, and here we'll say no, we need y modified dot shape and its first attribute. Then we need to pass some activation function. Yeah, so let's pass soft max as activation function, right? And finally, let's compile our model dot compile. Yeah, I want to compile it. So actually this autocorrector is pretty slow. So loss, so what should be the loss function? Let me use categorical cross entropy as the loss function. So categorical cross entropy. Okay, so no, it's single p, and then there has to be some optimizer. Let's use Adam as an optimizer. All these things are just the hyperparameters that you can play around with. And here we have an error. It says we have a syntax error. Yeah, that's right. So we were missing a parenthesis over here. Let's compile it. Awesome, it's fine. Okay, now let's start training of the model. So model dot fit, here we'll pass the features x modified, and we'll pass the labels y modified. Okay, and then we'll say how many epochs do we want to run it. Let's say 15 epochs. And what should be the batch size? Batch size should be, let's say 100 or 200 or whatever you want. And finally, verbose. What are verbose? Any guess? I've explained this in my last video, so please check it out. This is a beautiful thing. So let's run it, and it will take some time. Until then, I'm going to pause this video. So once the training will be done, I'll be back. Okay, and welcome back. So our model is being trained. Training is done. You can see that it has run for 15 epochs. By the way, this verbose 2, what it does, let me tell you, it actually displays this information for when you're going to fit the model or when you're going to train the model. So if verbose equals to 2, it will print the details like this. If verbose equals to 1, then it will just display a line over here, and if verbose equals to 0, then it will display nothing. So in epoch 1 out of 15, our total epochs were 15. So in epoch 1, we had this loss, 6.9 was a loss, and this is the time that took per epoch. And you can see that the loss is decreasing with the passage of epochs, and finally after 15 epochs we have 6.4 as loss. Now let's generate some content. So let's say string mapped equals to, let's select any random feature vector. What it does is, let's select x5. Okay, so what it does is, we want to generate some content that will come next to this feature vector, right? So we'll say for I in range, and here we'll say sequence underscore length, right? And then we'll say x equals to, we are again doing the same thing. We're going to do some reshape, and we are going to reshape our string mapped, and it will be reshaped in the following order. We'll say length of string mapped, and then we'll say again 1. So this will be the shape of x, and then we'll again do some normalization of x. So float, and here we'll say words, right? Not words, but actually the length of words. Awesome. So then we'll say predict index, and here we'll say numpy dot argmax, and from argmax we'll get our model dot predict, yes, model dot predict, and here we'll say x, we'll pass x, right? And then we'll say verbose equals to, let's say, let me put it equals to 0 for this time, okay, and just for the sake of change. And here we'll say seq or sequence equals to number to words, right? So okay, number 2 character. By the way, if you're wondering what is this number 2 character, so the thing is, in before training, I showed you how to work on words, but while training I changed my training data to characters. So if you are you can just write word, like word here. Okay, let me write character over here. Okay, so here I'll say value, right? And then I'll say for value in string mapped, and here I'll say string mapped, sorry, dot append. So here I'll say predict, so predict index, right? And finally we'll say string mapped equals to string mapped, and here we'll say from 1 to length of what itself, string map. So we will ignore the first character or first word, and we will take the rest of words. So training will go on until the number of sequences, and finally we'll be having a new string mapped, and this new string mapped will kept pasting its value on sequence. So finally we'll be having this sorry for this weird sound. So finally we'll be having this seq as our final final content. So let's run it, and Oh, so we have an error over here. It says words not defined. Yeah, it's right. So we had characters over here. So let me run it. No, same error. Okay, so we were writing wrong spelling, so we'll say words. Okay, it should run, and it is perhaps running. Yeah, perfect. So let's see how our sequence looks like. Let's display our sequence. And okay, so it doesn't look like quite good. So which means we have not done enough training, or we have not selected good batch size, or perhaps we have not selected a reasonable number of units over here. And in other words, we have not selected good parameters or good hyperparameters for our model. So let me pause this video over here and let me train it over several settings, and let me find a good setting for you. So here we go. So I have found some setting, and here you can see that this is the sequence that has been generated, or if we want to display it in a good sentence like format, so I'll do something like this, right? And here you can see that it has generated some text that is unseen, and our model has our model has generated this text. So this was the thing that we wanted to generate. Just one thing that I want to clarify over here. You might be wondering what this line is doing, so and why are we using this argmax, and what this argmax function actually do. This argmax function actually gets us the argument that has the maximum value, right? So if this model dot predict has, you know, this sequence length times values, or let's say in our case sequence length is 50, so it has 50 values, so it will get us the index that has the maximum value, right? So that will be our predicted index, and then we are converting that predicted index into, we are mapping it into our string, and then we are writing it onto our sequence and stuff like that. So guys, this is about it. And if you want to learn more about artificial intelligence, please visit our website and hit the bell icon. Also subscribe to the channel. Thanks.